Hi guys, so there was an error with my last video. The sound wasn't on, so there's a re-recording of the video that hopefully you can now hear my voice. So, piecewise and transformation functions. Okay, new unit today. We're starting the new unit today. Lesson 1, piecewise functions. Okay. We'll talk about what a piecewise function is in a few moments, but just to recall, okay, notation that includes some inequality notation. Okay, so remember, notation that includes the numbers less than or equal to, greater than or equal to, anything that has the little line underneath it or is a closed circle includes the number. So for example, if I have something like x is greater than or equal to 3, it means that we're including all the numbers that are greater than or equal to 3. So 3, 4, 5, 6, ... and so on. Okay, and vice versa. Notation that means not included does not have the line underneath the inequality symbol, or is an open circle, means it does not include. So x is greater than 3 means that we do not start with 3, but we start with the number that's greater than 3. So 4, 5, 6, 7, and so on to infinity. Okay? So piecewise functions. Piecewise functions are exactly what they sound like. If you look at here at the example, okay, this is a piecewise function because it's pieces of functions. We see 3 different pieces here, right? That is a piecewise function. So the definition of a piecewise function. The following graph is called a piecewise function because the function is defined by 2 or more different equations applied to different parts of the function's domain. A piecewise function is a function made up of pieces of other functions. Each piece is only defined for a specific domain. Notice that it appears to be composed of 3 segments, each a different linear function over a particular domain. Please note a filled circle includes that point, while an open circle does not include that point. Remember, we just talked about this. So this point would not include the number -3, while this point would include -6. That's what that means. So, part A, what is the domain and range for the first segment? So the first segment is here. So the first segment, the domain. Remember, the domain is our x values. So if I'm talking about our x values, I'll clean this up a little bit. For the first one here, I'm looking at the x-axis. So I go down to my starting point and I go down to the x-axis, I get -6. So my first value for the domain is -6. X is in between -6 and the end point for this function is -3. Now, because -6 is a closed circle, we put it closed. We put a line underneath the inequality symbol. Because -3 is open, we leave it open. No line. Alright, now we do the range. So the range is the y values. I'm still looking at the same line. Okay, only at this point I'm going over to the y-axis. So I take my starting point and I go to the y-axis. It starts at -1, so y is between 1 and the ending point is 4. So again, 1 here is a closed circle, so we put a line underneath it. And 4 is an open circle, so we leave it open. Alright, now we're going to do part B, the second line here. The domain, the x values, okay, the domain starts at -3 and goes all the way to 4. Again, we look at closed and open circles. -3 is closed, so we put a line, and 4 is open, so we leave it open. My range, okay, I'm looking at the y-axis here. Now, the range is a little strange because I go to 2 and I go to 2, right? There's no difference, so we just put y equals 2 for the range. A horizontal line is, all the y values are the same. Alright, and the last one. Okay, my domain, the starting point, we read from left to right, so I start here. It starts at 4, X is between 4 and the ending point is 8. So 4 is a closed circle, so I put a line. 8 is open, so I leave it open. And finally the range for this line. Okay, here's my starting point. The range starts at 6, so y is between 6 and ends at -2. Again, closed, open. So, more piecewise functions, okay? How many equations do you think you would have to use to write the rule for the following piecewise function? Okay, well, there's 2 lines here, so 2. Notice that it appears to be composed of 2 rays, each a different linear function over a particular domain, right? We have 2 lines, they're each different lines, so they're going to have different domains and ranges. So part A, what is the domain and range for the first ray on the left? So this one right here, we'll call this one number 1. Okay, so the starting point, the domain, the x values. Okay, here's my starting point, but really it's not a starting point, right? Because it has this arrow. It keeps on going and going and going to infinity. Okay, and stops here. So really when we look at the starting point, well, there is no starting point. It's going to negative infinity, let's say, right? This direction is negative infinity, while the other direction would be positive infinity. So x is between negative infinity and it stops at 3. Anytime we have an infinity symbol, it is an open inequality. Okay, it's not closed. It stops at 3, which is an open circle, so we leave it open. Now let's look at the range. Okay, I'm going to clear this so it cleans it up a little bit. The range for this function, well, again, it's still going to infinity. There's no starting point. So we're still coming from negative infinity to, well, where does it stop on the y-axis? Oh, 1. And again, open. Any infinity symbol is always open, and because there's an open circle here, we leave it open. All right, let's do the second line. Okay, the domain for the second line. Well, here's the starting point. We go down to the x-axis, that's 3. So x is in between 3 and up. There's no ending point because it goes on and on and on forever to positive infinity. Okay, this is positive infinity. You don't have to write the negative symbol. Remember, this is negative infinity. So, the 3 is a closed circle, so we close it up with the line. And infinity is always open. Now for our range. Okay, our starting point is here on the y-axis. We start at 4, so y is between 4 and there's no ending point, so it goes to infinity. 4 is closed, so close it up. Infinity is always open. Write a piecewise function for each graph below. Okay, so we're basically just writing a separate equation for each line. Remember, these are both straight lines, and our equation for a straight line is y equals mx plus b. Okay, and what we're really doing is we're searching for the m and we're searching for the b for our equation. Alright, so it kind of sets it up for you already. It says write the equation for the first piece. So we're going to call this piece number 1 here. So m means the slope. Okay, remember the slope always equals y over x. So, I picked 2 points. Here's 2 nice points, right? And I go up 1, 2, 3, 4, 5, 6. So that's plus 6 on the y-axis. Up and down is always y. So m equals y over x. My y value is 6. My x value, 1, 2, 3. So plus 3 on the x. 6 divided by 3 gives me 2. Okay, so my m is going to be 2. Now I need my plus b. I need my final piece here. B is my y-intercept, where it crosses the y-axis. So if I look at this again, I'm going to erase some things here, and I look at where it crosses the y-axis. Well, this line crosses the y-axis right here. y equals 1, 2, 3, 4. So my b is going to be 4. So now I fill in my b, plus 4. That's my equation for this line. Okay, we also have to fill in the domain. The domain for this line, the x values of this line, well, here's my starting point. I go straight to the x-axis, is -1, -2, -3. So it starts at -3 and it ends at x equals 0. Alright, now my second line. Doing the same thing. Okay? M is always y divided by x. However, okay, because it's a horizontal line, okay, think about this. How many do I have to go up on the y-axis to get to the second point? 0. How many do I have to go over? 1, 2, 3. 0 divided by 3 is just 0. That's my slope. Okay, so I can already fill that in. Y equals 0x. Now my b, where does it cross the y-axis? Well, it crosses right here at y equals 4. So plus 4. Now, special thing we have to remember about this is that 0 times anything is just 0. So really we get rid of this whole piece. And our new equation is just f of x equals 4. Okay, our domain for this line, we look at our starting point. Domain, remember, means the x values. Okay, so I go down, starts at x equals 0, and it ends at x equals 1, 2, 3. Alright, now it says write your final answer here. The reason it says write your final answer is because the way we write a piecewise function is we use f of x equals, and we use what we call these brackets. Okay, because both of our equations, this is both of our equations here, okay, equal f of x, we can kind of combine it. So I'm going to take my first equation here, I'm going to write 2x plus 4, and then comma my domain. -3 is less than or equal to x, is less than or equal to 0. Then I take my second equation, which is just 4, comma, my domain, 0 is less than or equal to x, is less than or equal to 3. And this is my answer for the question. This is the piecewise function that represents this graph. Okay? Last one for today. One more problem. Write a piecewise function for the graph below. Okay, we notice there's 3 lines, right? So we're going to have to write 3 different equations. Equation 1, equation 2, equation 3. So I'll label it 1, 2, and 3. So let's look at equation 1 first. Write the equation of the first piece. So the equation of the first piece, okay, the equation of that horizontal line, remember, my m equals y over x, so my m. Now I could pick 2 points here, let's just say, and on the y-axis I don't have to go up or down to get to the second point. So my y is 0 and my x is, let's see, 1, 2. I have to go over 2 places. 0 divided by 2 is 0. So my slope is 0. My y-intercept, where it would cross the y-axis here, would be -1, -2, -3. So really, remember, 0 times x is just 0. I can get rid of that. Really, my equation is f of x equals -3. This is my equation. I know it doesn't have x in it, but it's still an equation. Now, identify the domain, the x values for the first piece. Okay, well, it starts, remember, it says x is less than what? Well, if I look at the y, or the x-axis here, and I go up, this is -1, -2. the line continues to go this way. So x is really less than -2, right? It starts at -2 and goes to the negative zone, the opposite way. All right, let's erase some stuff here. Second equation. Okay, we're looking at the second line on the graph. Okay, write the equation of the second piece. So I need my m, right? M equals y over x. So I pick 2 points and I go up. Here's my y value, right? 1, 2, 3, 4. So y is +4. Divided by, now for my x. I started here. 1, 2, 3, 4. So x is also 4. 4 divided by 4 gives me 1. So my m value is 1, or just x. Now I need my b, right? Where does it cross the y-axis? So this line crosses the y-axis right here at y equals 0. So let's clean this equation up, right? I don't need the 1 in front of the x. 1 times anything is itself. And I don't need the +0. So really, this is the equation f of x equals x. Identify the domain for that piece. Well, the line is in between the x values of -1, -2, and it ends here, 1, 2. Right, this is the x-axis. All right, finally for our last piece here. Then write the equation for the third piece. Okay, here's the third piece. F of x equals, well, here's 2 points. Right, it's a horizontal line. So if it's a horizontal line, I can't go up and down to figure out how many places on the y-axis we should go. So y equals 0. For my x, I have to go over 1, 2 to 2. 0 divided by 2 is just 0. Oops, sorry. I should do this. M equals y over x, which equals 0 divided by 2, which equals 0. So we know that my m is 0. Okay, so we have 0x, and now we find the plus b. Where would this cross the y-axis? Right here, which is y equals 1, 2, 3, 4. Y equals 4. So if we clean this equation up, I don't need 0x. 0 times x is 0, so we get rid of that. F of x equals 4. Identify the domain for that piece. Well, all of the x values are greater than, let's see, 2. So x is greater than 2. Now to write our final answer here, just like we did before, each equation is equal to f of x. So we start with f of x equals, and now we're going to have 3 different equations in here. The first one, f of x equals -3, comma, the domain. Next one, f of x equals x, comma, its domain. And the last one, f of x equals 4, comma, its domain. And this is your equation for this piecewise graph. Alright guys, good luck. Try the assignment that I have for you. And if you have any questions, you can always email, text me, or find me on Google Hangouts. Bye guys.